Governor Nome, in her state speech in 2019, her first part of her governorship, challenged the state to come up with the next big idea for South Dakota's economy. So a group of us came together and promoted this idea of getting South Dakota more deeply engaged in the bioeconomy.
Each step of the way is the product of different groups coming together over a shared vision or a shared sense of need. And that shared sense of need is harnessing South Dakota's assets to respond to a global marketplace need. The global marketplace is driving a need for products made from biological resources, bioproducts. That's how we're responding to the limits of petroleum. And petroleum is a base for common consumer products. South Dakota can respond to that need.
We have two fantastic engineering schools in this state. One at SDSU, one at the School of Mines. And they need to work together because they have different strengths. And it's for the people of South Dakota. So I was very impressed with President Rankin and President Dunn when they came together on the same vision and said, we need to do this together. Students will be actively involved. That will help make the difference. And the research from these two universities will be the primer for what we see, inventions from the industry, commercialization, moving it forward so that we, the people of South Dakota, are going to be the beneficiary. When you're taking that last cup of oil out of the ground, what are you going to use then? That's where the biofuels, the bioproducts are going to make the difference.
Industry will get to see more and more of that as we want to, as a society, use more renewable sources. So I think soy has a great opportunity to be at the forefront in that, to be a major player.
Well, both universities, our goal is to develop the future workforce. People that can make a difference in the world, and that's really the homegrown talent that we have here. And so by putting those two things together, it allows us really to collaborate and work on research. And even though we can do the research, it's hard to turn it into a commercial product unless you can mature that technology, scale it up from off that bench so that it can be at something that you can produce and sell. Who knows what that next product's going to be, or that next bioproduct that's going to replace something like the plastics we talked about earlier today. So the future is bright, and I'm not sure where it's all going to go. Thank you all for being here. CNAM Bio works in collaboration with Dakota Bioworks on the eastern side of the state, providing proof of concept and scalability of products for commercialization. Personally, I look at Dakota Bioworks as an umbrella organization that oversees the Poet Bioproduct Center in Brookings, but it also involves the researchers and the research labs that we have at South Dakota State and Mines. Research labs like the one you're going to see today. Thank you for being here to celebrate not only the CNAM Bio facility, but also the partnership between Mines and South Dakota State, as well as Dakota Bio is.
My name is Craig Arnold. I'm the president and CEO of Dakota Bioworks. And Dakota Bioworks is a pilot scale facility, and what that means is we work with scientists that are inventing things on the benchtop, whether here at School of Mines or SDSU or wherever the case may be, wherever they come from. And one of the big things that you have to do when you're going to try and commercialize a new technology is show that you can make it in some sort of a volume, and then also understand, well, what does it actually cost to make it?
What we have here are various scales of working with these microbes to produce products, but it's not straightforward to go from a test tube, say, to commercially producing a plastic or some other product. And so you have to scale up because you have to take into account what the microbes are doing to keep themselves functional.
Right.
And then you're trying to take in the products that they also produce. And so the scale up is really important as you go into larger and larger volumes of processing.
And so what we'll do is we'll work with these inventors, and we've already identified some both here at the School of Mines and at SDSU, and help them scale up. So the first step is they'll go into a small bioreactor, something that really many of them have no experience with. They're used to working with glass flasks. And we'll help them graduate from one scale to the next, to the next, and to the next. And when you're using bioreactors or precision fermentation, you need about 10 to 30% feedstock. So that's how they step up and go from bench scale to what's called pilot scale, which is 1,000 liters. And that's the first big hurdle that a lot of startups can't make as they try and figure out how to commercialize their new invention.
So, in School of Mines here, especially the C&M Bio Center, we are establishing from a ground level to a pilot scale level. So that's most important. Sometimes in most of the universities, the research has been stopped in the bench scale level. So if there is no advancement going to scale up, then that research and the time is not getting utilized enough. So the idea here, especially the C&M Bio Center, is we work with Dr. Sani's group there and Dr. Salem, and so we have a team here that is developing from a microbe level from a 1 liter flask to 10 liter flasks. So you take materials from small scale level, you optimize things in there, and then you go to the next stage level, 10 liters and so on. Scaling up is itself an art. So every parameter that you're going to use in there, it'll be unique for each microbes or bacteria that's going to be in there.
If we can get the processes to work at this level, then we can go across the state to Brookings, to Dakota Bioworks, and continue that upscale process to a level where we can say to a company, say this is working at a scale that would actually mean that you could get a viable product from it.
So it's just a really critical step between research, which is great,
Yeah.
to actually getting something out into the marketplace. So at the end of the day, what we're really trying to do here is take more organic feedstocks of biomass from the forest or from crops or whatever, and then really replace some of our petroleum-based products. Is that
That's
right?
exactly right. So instead of using petroleum as the feedstock, we now use what we have in abundance in the state, which is waste agriculture and waste forestry projects, which are a huge amount, in huge amounts. And we're very well poised then to be a leader in this new bioeconomy that's emerging in the US and across the world.
There's a limited supply of petroleum in the ground. We're not making more of it. I guess if I was doing a startup and I didn't want to worry about feedstocks, I would say, make it out of seawater. We're never going to run out. But don't make it out of oil, because we are going to run out. And the next best thing is make it out of plants, because every spring here comes a new crop and a new feedstock. So it's very much sustainable and good for the environment, certainly good for South Dakota's economy as we look to develop these new high-value products out of agriculture, forestry, about the with the feedstocks that we have here in the state.
First, before you go even here, you need to get a lot of work done on the 40-liter reactor.
Well, let's go look at that.
Yeah. So you come into a 40-liter reactor and then you optimize conditions there. So what we use here as a raw material is water and whatever the agriculture waste, like corn stalks, soybeans, and there's whatever the corn husks and things. So we shred them and get them into a biomass, and then you put them in there, and we have bacteria and microbes that's going in there too. So you create a nice ecosystem where the bacteria can grow inside. So it will start to grow those bacteria, the microbes in there. So we genetically modify those things too, so that it can keep on producing.
Is there a certain time where that
It
takes
depends
place?
on the condition of what bacteria that you're using, what microbes you're using, and what of resources, like if it's a soybean or is it like a corn stover, it depends a little bit differently. So it can start from maybe 6 hours to 3 days processing time.
So hours to days,
Yes,
not weeks to months.
No,
okay.
it's not going to be that
Does that
critical.
change once you scale to a bigger?
Not really. So it's once it's there and you create a biomass of materials here. From here, you go to the next stage. So once those bacteria are made, we have to extract those cells from the bacteria. That's where the centrifuge comes into play. You have to rupture the cell and extract those polymers. Then we use chemical treatments to rupture those and extract those cells, and then use solvent extraction method to extract the polymers and so on.
And so then we take the polymers out, and then
is where the magic happens, right? So once you have the raw material, the polymers there, you want to make a product out of it. It could be simple as making a sheet for agriculture purpose, or it could be having like a panels or whatever for a structural or semi-structural parts for anything you wanted to make. It could be automotive industry, or it could be music industry, where acoustics is another big area that composites are playing a huge role. So this is the C&M Biocenter. We have a Cape lab, which is a mother of this thing because it's a part of this lab, right? So where we have extruders, injection molding capacities, and compression molding, and thermoforming, vacuum forming, you name it. There's all the things we have.
so at that point, it's very similar to the petroleum-based fibers.
Exactly. Pretty much.
Okay.
Once you make those in either a pellet form or a powder form, once you make those, the main thing is to scale up this. How do we scale up to the level that can make economically sense, right? You don't want, if the nylon is like $33 per pound versus if people wants to pay $10, $20 per pound, there is economical difference. How are we going to make this economically feasible? It's by going scale up. It opens up the whole area. If more testing happens here, tensile testings and compression testings. We have injection molding capabilities for rapid tooling, rapid things. Every 30 seconds, 60 seconds, you can make a product. Once you make the pellets or powders, you put those pellets in here, and then you add if there is any reinforcements or whatever you want on this side, and you can compound them and make whatever you want at the end of the day. So this can be made as materials like this. So have compression molded materials. It's a differential cover for automotive industry.
Yep.
Proud to say most of these materials are made from recycled materials. Recycling carbon fibers from wind turbine blades, aerospace industries. We work with a lot of companies, big time, and like Vertega and so on. They recycle carbon fibers, so we can get those materials in the form like this. This is carbon fiber.
Okay.
So
you take that and
and this is what's going to be this is in a chopped form, but the big form is right here.
Okay.
But this one has a 24,000 filaments inside. So each one is like a 6 microns diameter.
Yeah.
So it's thinner than the hair.
As I say, it's just
It's
like
so
cotton
hairy.
candy.
Yeah. So
That's
the
very
challenge is
interesting.
to how do you make composites from here to something like this, or you can make a pressure vessel, or panels like this.
And then so the new CNAM is really trying to get from waste material to this.
To this material, exactly. And this is a polypropylene with a bamboo. So they have good acoustics. When you blend it with a natural fiber to make a product like this, so it's going to have you are doing everything natural. You use that polymer, and fibers like this could be natural fiber, flax, bamboo, canaf, you name it. There's a lot of natural fibers out there. you make composites like this, will be structurally strong. So then the whole thing is biodegradable. So you asked about 3D printing. If I can make this can be gone into 3D printing with any material, right? So the nice thing is if it's a good product, then when you snap this, it just should snap like this. Once you make the polymer to get to a product, we can do that much more easily. And we can make sheets from this, we can make pellets from this. We do a lot of activities.
Hopefully the goal is to move beyond, academia, and yeah, we're going to come up with ideas and innovate and do all those things in academia, but then transfer that out into the actual marketplace. And that's
Absolutely.
why this thing, what we're sitting in here, the Poet Bioworks or Poet Biotech facility, is so incredibly important. Is that right?
That's absolutely correct. So we call that process, the term in the industry, so to speak, is technology transfer. And so the building that we're in right now is the Poet Bioproducts Center. That's a specialized facility. Dakota Bioworks is a nonprofit organization of the South Dakota Board of Regents, and Dakota Bioworks will provide the expertise to make the Poet Bioproducts Center work well for industry and for the universities.
So we're here at the Poet Bioproducts Center here on the Research Park at SDSU. And people may say, oh, Poet Bioproducts, well, that doesn't have anything to do with soybeans, but that wouldn't be the case, right?
No, that's we wanted to be a part of it as well. South Dakota corn, Poet, South Dakota soybean are all a part of it, and wanting to create opportunities to use our products, take it from a laboratory to a business model. And so we're excited on the soybean side to be able to move, use the soybean products. Either could be a byproduct of already processed soybeans or straw. It's unknown exactly how it will be, but we're just excited to be at a place to be involved with it.
Basically right on or off the campus, kind of right here, it's a partnership where we're at this research park, which is designed to do exactly what you're talking about. Take some of the really cool things that are going on here at SDSU and out at School Mines and provide that missing step where we can start to actually produce that at a commercialized level and see if it's a scalable enterprise.
And that's what's so good about this, because we can take that research we have at Mines, bring it over here, let them run it through the different stages. You're going to get better license terms. It's going to be more successful for the startup company and create jobs in South Dakota, which is really an important part. We want more of our kids to be able to stay in South Dakota once they graduate, if they want to.
This is kind of the secondary step of research. So the research will happen at the School of Mines in their laboratories, and then here at SDSU in our laboratories. And then they'll bring an idea related to bioproducts, related to fermentation, and they'll bring it here, and then through, and I guess it's a secondary stage of research to scale it up, to see if you can make it work in an industrial situation. And that's really tricky, because something might work in a beaker, in a small volume, but you've got to make it work in large volumes, and it's got to be, you need to be able to repeat the process. So there's a lot of steps to go through, and that's what this lab is here to do.
Pretty cool. I mean, and just the fact that you can put this logo right into it. What a nice touch. Very
pretty exciting for farmers.
Yeah,
to be able
absolutely.
to do that.
Yeah. Well, I think that's one thing that's so cool and unique about South Dakota. Our show is called Homegrown, and when we talk about this bioeconomy, it's not just corn, it's not just soybeans, it's not just forestry, but South Dakota is well positioned to be a leader because of the diversity from east to west in our state. I think that's really awesome, and it's just what a cool thing to have this research lab all the way across our state, and with the feedstocks that we have here. It's just really awesome.
Yeah, no, it really is, and I did a SD Mines with some partners, startup out of here, a successful startup, and in fact, The downside to the whole thing is the company that bought us picked up everything and moved it to England. And so I want to do another one, but this time I want to make sure that it stays here.
Yeah.
And frankly, we have the agricultural background, we have chemical engineering at SD Mines, we have ag programs over at SDSU. We have everything we need. Most importantly, we have the feedstocks that we need to sustain and continue to produce high-value products out of the bioeconomy.
Well, we wish you the best of luck, and we
Thank you.
thank you for joining us here in Homegrown.
Yeah,
Appreciate
thank
it.
you.
Well, and there's all kinds of partnerships with this, starting from, the Soybean Utilization, or Corn Utilization Council, Soybean Research Promotion Council, SDSU, POET. Yeah, I can't even name them all. I don't know if anybody can, but you've done a great job of articulating that vision because, as we saw today, a couple hundred people here to see this come to fruition. It's got to be pretty satisfying.
It's all right here, and we just put the puzzle together. A couple more pieces to come together before that becomes a reality. But I hope that helps your audience understand what we're trying to do.
As South Dakota responds to that need with new products, that adds value to South Dakota's commodities, which adds value to the South Dakota acre. And that's what we're trying to do, big picture.
Well, it's just awesome. You think about maybe what drove the economy over the last 50 years, but what the visionaries are saying is this bio research is really what the global marketplace is yearning for.
That's right.
And we are well positioned in South Dakota to be a leader in that. Not only because of our climate, what we grow, east to west, from the forest industry to the crops and grains, but because of the visionaries and leadership such as yourself to start doing that research and lay the groundwork to be the leaders for the next 50 to 100 years. I think that's really amazing. I think it's really cool.
All of the different ag groups were in support of doing this. That doesn't happen every day in South Dakota. This is really going to be the true beginning of a new future for South Dakota.